3 is on hyperbolas. So you guys started the ellipse assignment. Okay, the ellipse and hyperbola equations are almost identical if you look at the two equations. The only thing that's different is you have a minus for a hyperbola instead of a plus. Okay, but they're almost identical. The other thing that is true is that it says, unlike an ellipse, A does not have to be the larger value for the hyperbola. Okay. We also talk about the different axes. We don't have the major and minor axis like the ellipse. We instead have the transverse and conjugate axis. So the transverse axis is what's going to connect the vertices. So transverse, I would say it equals vertices. So that way you can see the ver, right? And then the conjugate, that's what connects the co-vertices. So co and co. Okay, so that's kind of how you can remember. Okay, for the hyperbola, instead of having c squared equals a squared minus b squared like we had before, c squared is equal to a squared plus b squared. Because c is actually a little bit longer than a. If I talk about the foci are actually like inside the ellipse. So this ends up being the distance c. Okay, so c is bigger than a, so it's a squared plus b squared to get that bigger value. Okay, just like before, I don't want you to memorize all of these formulas that are given. I want you to just know how to use them, how to sketch a graph, and come up with where the vertices and the co-vertices and so on are. So this should be super simple if you guys already started your homework. If you guys can understand the ellipse, it's related to it. All right, so let's try this. So example 1, so it says graph the hyperbola, determine the center, the vertices, the co-vertices, the foci, and the asymptotes. Okay, so what do you guys guess that your center is? It's 0, 0, right? Just like before, you can see like the h and the k are not there, so it's 0, 0. All right, A is not necessarily the smallest, or it's not necessarily the largest, I mean. It could be smaller. Okay, it's just whatever's first. So you might want to write yourself a note. A is always first, not necessarily largest. Okay, and this is different than an ellipse. So if you guys remember when we had ellipse equations before, I told you that I would try to trick you, and I would write something in this form. And you would have to know that 5 goes up and down, and 4 goes right and left. So it's actually vertical because it's longer on the up and down axis. Does that make sense? And what I told you is the best thing to do is to rewrite your equation right from the beginning, so that the y was bigger. So you always say, okay, now I see it, the y comes first, so it's going to be a vertical, okay? That's why I told you to do that. I told you to switch it around, because then you can just remember, oh, as long as I see it in the correct form, whatever's first is going to be my a, okay? So anyway, so a is 3 in this case. And b is 4. And since a is underneath the x value, it's going to move right and left. And since b is underneath the y value, it moves it up and down. So when we sketch it out, we start at 0, 0. And we go up and, or we go right and left 3. 1, 2, 3, 1, 2, 3. And we go up and down 4. So tiny little dots. So right and left 3, up and down 4. And don't be tempted to draw on your ellipse. A lot of people just kind of draw the ellipse from here. It's not an ellipse, it's a hyperbola. So we have different steps to drawing it. The first thing we do is we draw in a little box. And we don't connect them like some people are like, oh, just connect the dots. I'm going to draw a box, right? That's not how it works. What we do is from those 4 points, we go straight over and straight down. Okay, so we're going to do that. So we're going to go straight over and straight down through those points. So we create a little box. Now the whole point of having the box is it draws in what we call asymptotes. Okay, so I'm going to connect from one corner through the center into the other corner. From one corner through the center to the other corner. These are always hard to draw. Sometimes people like get the center, but then they totally miss the other corner. Might need a ruler when you do your homework. All right, is this a vertical or a horizontal hyperbola? What do you guys think? No, it's horizontal. 50-50, man. All right, yeah, it's horizontal because it starts with x. Okay, so since it started, you had x squared over 9 minus y squared over 16 equals 1. Since you have an x right here, it's horizontal. Because you definitely can't switch this one around. You can't just switch the terms. There's a minus in between them, so it's the first one. Okay, so a horizontal hyperbola opens like that, like to the right and left. Okay, so what we're going to do is from this vertex point, we're going to go along the asymptote. We hit the vertex and then along the asymptote. So an asymptote is a line that you're going to get closer and closer to, but you're never going to cross. Okay, these little slant asymptotes, we call them. So that's your hyperbola. So it kind of tells us how wide it opens. Yeah. Because it started with the x. If it starts with x, it's going to open like this. So like x squared is going to be like this. If you had a vertical, it would start with y squared, and it would open like this. Yes? Yeah, since it's a minus, you can't like switch them around. Like for an ellipse, if you had x squared over 9 plus y squared over 16, that's actually going to be a vertical one. Because you can move it around, there's a plus in between them, right? And for the ellipse, what you're saying is what was the biggest term on the bottom? Like what one was the, what's A? A is 4 in this case. It goes up and down because it's under the y value. So it's kind of confusing. Oopsie, that's weird. All right, let me erase. All right, so let's go through all this information. So we have the vertices. So from my center, remember your center was 0, 0. I didn't quite move it all the way back to where it was. There we go. All right, so my center was at 0, 0. And I moved right 3 and I moved left 3. So my vertices are going to be 3, 0, and they're going to be negative 3, 0. So if I talk about the axes, this is called the transverse axis, if I ever refer to that. So it's really kind of the distance between those 2 points. We call it like the length of the transverse axis, the distance between the vertices. Okay, the co-vertices, I'm going to go up 4 and down 4 from the center, so it's going to be 0, 4 and 0, negative 4. The foci end up being like inside the 2 hyperbolas, like in there. Okay, so we need to figure out what that is. So we do c squared equals a squared plus b squared. Okay, the way I remember which one's which is for an ellipse. In your main equation, like in the x squared equation, the y squared, and so on, for an ellipse, you had a plus. Its c squared equation was the opposite. It was a minus. So for hyperbola, if you have a minus for the main equation, then the c squared equation is going to be a plus. They're opposite each other, okay? And it will make sense, too, if you don't use the right one, because you'll be like, wait, my point isn't in the right spot. Okay, so if I have c squared, I'm going to get a squared is 9 plus 16, so I get c squared equals 25. So c equals 5. That was nice to you again. I gave you a nice whole number. So from the center, I'm going to move right 5 and left 5. I missed it. Okay, so it's going to be 5, 0 and negative 5, 0. All right, and then the last thing that we need are the asymptotes. Okay, we need to find the equation of, I'll draw it in another color, of this line right here. Okay, what's the slope of that one that's rising up? The slope, how much did I go up? How much did I go over? I went up 5, oh, up 4, right? Over 3. Do you guys see it? Count your rise over run. You go up 4 over 3. So your slope is 4/3. And then it goes through the point 0, 0, so that's your y-intercept. Your b value is 0. So you get y equals 4/3 x plus 0, right? So y equals 4/3 x. What about the other one? With this line right here. What's its slope? Yeah, it's down 4, right 3, negative 4/3. So it's exactly the same thing, only now it's a negative for the slope. Those are the two asymptotes. So maybe I'll do and. So y equals 4/3 x and y equals -4/3 x. So a lot of times we shortcut it, and instead of writing both of them like that, you'll see me write it as y equals plus or minus 4/3 x, which means there's two lines there. One's the positive slope, one's the minus slope. Okay? All right, let's do another one. So they're not always centered at 0, 0. That's where it's really easy. Everything's symmetric. Sometimes they're shifted a little bit, so let's do one where it's been shifted. Okay, so this one we have centered. We have an h and a k value that's not 0, 0. So where is it centered? Be careful. Where is it? Here's your h, here's your k. -2, 1. Remember I told you last time when we were doing the ellipse equations, don't mix it up. It's always the x first, then the y. If you mess it up and you say 1, -2, then you're going to get every single point wrong because your center is in the wrong location. So moving up and down and right and left from the wrong center is going to give you wrong points. So I'm going to have -2, 1. Okay, a is the first value, so it's 5. So b is 4. Is this going to be vertical or horizontal? Vertical, because it starts with a y. So that means it's going to be a hyperbola that looks like that, like an up and down opening. So from my center, I'm going to go up, right, since I was underneath the y. I had 25 underneath the y. I'm going to go up 5 and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And since I have the b value underneath the x value, I'm going to go right and left 4. 1, 2, 3, 4. 1, 2, 3, 4. So those 4 points give me the points, kind of the guiding points to make that box. So I'm going to go straight over, straight down. And then once I have the box, I draw in the asymptotes. Sometimes it helps if you start in the center and then kind of extend it out. All right, and then it's vertical, so we're going to open up and down. So we're going to have that, and we're going to have that. All right, so we need to find our vertices, our covertices, the foci, and the asymptotes. So our vertices are actually on the curve. Okay, the covertices never touch the curve. They're just kind of making the box shape. So your vertices are the ones that are up and down. Okay, so if I'm going to find those, I went from my center, which was -2, 1, and I went up 5 and down 5. So if I'm at -2, 1, and I go up 5 and down 5, I'm going to be at -2, 6, and I'm going to be at -2, -4. Do you guys see it? That's where those equations came from. It was like HK was your center. So you would have HK plus A and then H, K minus A. That's why I said don't memorize the formulas, just know what's happening, right? So you're adding the A value to the top and the bottom. So we have -2, 6 and we have -2, -4. All right, the covertices. The covertices are on the right and the left. They help us draw in the box. So I was at -2, 1, and I moved right 4, so I'm going to be at 2, 1. And I moved left 4, so I'm going to be at -6, 1. Yes?
Doesn't matter if like the vertices and covertices
Like you switched them? You wrote -6, 1? Yeah, that's fine. All right, the foci. So I'm going to do my c squared. So remember, c squared is equal to a squared. It's the opposite sign of what was here. So since I had a minus, it's going to be plus. Yes?
How do you know which are
The vertices are actually on the graph. Like, if I have a graph like this, this is a vertex, this is a vertex. The covertices are just these invisible ones over here that help us draw the box. So if it was a horizontal one, the vertices would be here, and then the covertices would be up and down. All All right, so I have c squared equals a squared plus b squared, so I'm going to have c squared equals 5 squared, which is 25, plus 16. Oh, this is not a nice one. I didn't make it 3, 4, 5 like I've been doing. So this is 41, so c equals the square root of 41. Lovely. It doesn't reduce down at all. I do know that it's going to be somewhere up here and somewhere down here. Like it's always going to go around. You can kind of estimate if you want with a decimal approximation if you want to. But basically what we're going to do is if we were at that -2, 1, right, for our center, and from that center I go up a certain amount, right? So this amount right here would be the square root of 41. If I go up square root of 41 from -2, 1, what am I going to get? -2, 1 plus the square root of 41. It's going to be weird looking. And then the other one's going to be -2, 1 minus the square root of 41. So you're adding to the y value and you're subtracting from the y value. So those are the foci. So I told you last time that you could have weird ones, especially on Math Excel. I'm usually pretty nice. Most of them I give you good ones. All right, so we're going to have that. All right, and then this time the asymptotes are a little bit harder too because we can't really tell where the y-intercept is. Okay, so it's going to be a little bit harder. So I don't want you to write it in the form with the y-intercept. I don't want y equals mx plus b. I actually want the easier form, which is the point slope form. So that's very nice for me. So you'll see why. So what is the slope of the asymptote that's going upwards? Yeah, you went up 5 and you went over 4. It comes from your a and your b, right? You went up 5 over 4. So we have 5/4. And then it goes through that point, -2, 1. Well, we write the equation of a line that goes through -2, 1 with slope of 5/4 like this. Y minus 1 equals 5/4 times x minus -2, so x plus 2. Right? Do you guys agree? It's point slope form. Well, what about the other one? Well, the other one just has a slope of -5 over 4, but it still goes through that point, -2, 1. So it's the exact same equation, except the slope is opposite. So what we do is we write plus or minus in front. So that gives both asymptotes. Does that make sense? Do you see why we like point slope form? It's much faster than finding the y-intercept. Okay. All right, let's try another one. So as you're doing this, don't just like blindly write down what I'm saying and not pay attention and just kind of copy notes. Okay, you should be thinking about it. You should say, okay, is this vertical? Is it horizontal? What's my A? What's my B? Where's my vertex going to be? Where's my covertex going to be? You're going through all of these steps in your head. Yes?
Is that -2 versus?
Which one?
Y minus 1 plus or minus 5 plus.
Yeah, because it's y minus y1. It was the point -2, 1. So if you have the point -2, 1, this is your x1, this is your y1. All right, so let's go through this one. So make sure you're paying attention, you're trying it on your own. Okay, so think about it. What is the center? 3, -4, good. Okay, is this going to be vertical or horizontal? Horizontal, because you start with an x. The number that's underneath the x tells me how much I move right and left. The number that's underneath the y tells me how much I go up and down. So I'm going right and left 3, and I'm going up and down 6. So from that center, I'm going to go right 3. And I'm going to go left 3. Are these going to be the vertices or the co-vertices? If it's opening horizontally, it's going to be the vertices. So let's go ahead and write them down as we're going. So I moved from my center, which was 3, -4, and I moved right 3 and left 3 from that center. So the value that's changing is my x value, right? I'm adding 3 to it and I'm subtracting 3 from it. So I should get 6, -4, and I should get 0, -4. And it makes sense. We can see it on the graph. All right, now I do my co-vertices. So from the center, I move up 6, 1, 2, 3, 4, 5, 6. And I move down 6, 1, 2, 3, 4, 5, 6. So those points, if I went up 6 and down 6 from my center, I add 6 to the y value and I subtract 6 from the y value. So I'm going to have 3 comma 2, and I'm going to have 3 comma negative 10. Okay, once I have those 4 points in, those are the 4 guiding points I need to draw on the box. So draw on the box. And now I draw on the asymptotes. So like I was saying, sometimes it's easier to start on the inside of the box and then extend it out, because it gets a little bit hard once they're really slanty. Or you could use a ruler. We said that it was opening horizontally. So I start from my vertex and I draw in the curve. Like that. So I had the point 3 comma, oh sorry. So now I need to do my c squared thing. So I have c squared equals a squared plus b squared. So I get 9 plus 36, which is 45. So that means c is the square root of 45. I don't leave it like that, I reduce it. What do you get when you reduce it? Yeah, 3 root 5. Okay, and then think about where we're going. So from the center, which direction am I moving? 3 root 5. Yeah, I'm moving to the right and to the left, right? So what I'm going to do is from that center, I'm going to add on 3 root 5. So what I'm doing is I'm adjusting the 3, the x value. So I'm saying that instead of just having 3, I'm going to have 3 plus 3 root 5, comma negative 4. And I'm going to have 3 minus 3 root 5, comma negative 4. So I just add and subtract from the x value of the center. Okay, almost done. Last step, we need to find the asymptotes. So we think about the slope. So let's think about the slope of the line on the right, the one that goes up, I guess. Shouldn't really say on the right. The slope that goes upwards. So it's going to start from the center, and we went up 6 over 3. So if I have 6 over 3, that's going to be 2. And then it has that center, which was 3, negative 4. So we write the equation of the line with slope of 2 going through 3, negative 4. That's when we do our y minus y1 equals m times x minus x1. We're using that form. So I'm going to have y minus a negative 4, so plus 4, equals m, which is 2, times x minus x1. So I get that. And then the other asymptote is exactly the same, but it's a negative slope. So there's a plus or minus. Make sense? That's everything. So if you can graph it, you can get every single thing that you need. All right, so you might have some like this where it just tells you a couple different things about the curve. These are a little bit easier. You don't have to find everything on the curve. So on this one, it says center is at negative 1, comma 3. So I always say a rough sketch helps. So negative 1, comma 3. I should have planned better because now I see I have negative 1, comma 9. So 4, 5, 6, 7, 8, 9. Okay, those are the two, well, I guess one's the center and one's the vertex. So it's going to go up from that vertex, and then you'll have another one down here. Okay, we don't have to find the other one. Now it tells us the co-vertex is at 4, comma 3. It's here. So if I was drawing in my little box, I have those 2 points. Can you find A and B? What is A? Yeah, how much do you go up from the center? 6. So A is always the one to the vertex. Okay, what's B? How much do I go over to get to the other point? Count. I was at negative 1, I go over to 4. 5. Is it going to start with x squared first or y squared first in the equation? Y squared, because it's vertical. So I'm going to have something with y squared minus something with x squared equals 1, and then I have some kind of denominators. Right? It looks kind of like the ellipse equation, just a minus in between. My center was at negative 1, comma 3. That was my h and my k. So I'm going to have y minus 3 squared, and I'm going to have x minus a negative 1, so plus 1 squared. And then my a was 6, so I'm going to have 36 on the bottom of the y, because that's how much I went up and down 6. And then I'm going to have 25 below the x. You see how it works? Okay, B. B is also vertical. So my center is at -3, 4. My A is 3. So if it's vertical, I'm going to go up 3. And I would also go down 3. And then my C is 5. So I don't have to draw a perfect sketch, but if I need to find what B is, I do C squared equals A squared plus B squared. Do you guys see what it's going to be? Yeah, it's a 3, 4, 5 triangle, basically. So I get B equals 4. I'd have 25 minus 16, which is, or 25 minus 9, which is 16. Square root of 16 is 4. Okay, and since it's vertical, I start with my y. So I'm going to have something with y squared first. Oops, minus. Okay. So I'm going to have y minus 4 squared, and then I'm going to have x minus -3, so plus 3. I go up and down 3, so I'm going to have 9 here. I go right and left 4, so I have 16. That's your answer. Whoops, I hit something. Now it's going to record my face, apparently. All right, is that it? Was that our last one?